For each of the practice problems in this video, you need to do four things. First, you need to figure out what the products are going to be in the reaction. Second, you will need to balance the equation by figuring out the coefficients. Third, label the physical states for each substance. And then fourth, determine which of the 9 types of reactions this one happens to be. So for each problem, go ahead and pause the video momentarily and then work it out on paper, and then you can go to the next slide and you can see what the answer should be. If you look at this reaction, we have an element reacting with a compound. So it has that A plus BC format, which means it's got to be a single displacement reaction. To figure out the products of the reaction, aluminum, of course, is going to form a positive 3 ion, therefore it's going to need 3 chlorides, and that's going to leave the iron by itself. To balance the equation, because aluminum is a plus 3 and iron is a plus 2, we would need 2 aluminums to give us 6 pluses on the right and 3 irons to give us 6 pluses on the left. For physical states, aluminum and iron are both metals, so of course they will be solid. Chloride has a charge of -1, and therefore FeCl2 will be aqueous, and AlCl3 will also be aqueous. When we only have a single substance, decomposition is really the only option. So the HBr is going to have to break apart into hydrogen and bromine. And since hydrogen and bromine are both diatomic molecules, you have to write it as H2 and Br2. To balance it, we have 2 hydrogens and 2 bromines on the right, so we would simply need 2 HBr. Hydrobromic acid would, of course, be aqueous, as all acids are, and from the periodic table, hydrogen is a gas and bromine is a liquid, and of course, this will be a decomposition reaction. H2SO4 is, of course, sulfuric acid, and KOH is potassium hydroxide, so we have an acid and a base, which means it's got to be an acid-base reaction. To figure out the products, the potassium will go with the sulfate, and since potassium is a +1, we would need 2 of those to go with the sulfate, and then of course the H's and the OH's go together to form H2O. To balance acid-base reactions is pretty simple. Just make sure the H's and the OH's and the H2O's are all equal. So with 2 H's, we'll need 2 KOH, and we'll get 2 H2O. Acids, of course, are always aqueous. Potassium compounds are always aqueous. And again, potassium means this one's aqueous, and water, of course, will be liquid. With a carbon-containing compound and oxygen, we can tell this must be a combustion reaction, and so the products will have to be carbon dioxide and water. To balance the equation, we have 5 carbon, so we'll need 5 CO2. 10 hydrogens would give us 5 H2O, and then if we add up the oxygens, we have 10 O's here, and another 5, that's 15 atoms of oxygen. That would mean 7.5 O2s. Of course, we can't have an odd number or a fraction, so we simply double the coefficients and make them 2, 15, 10, and 10. For physical states, C5H10 is a liquid, but again, I wouldn't expect you to know that. But you should know that oxygen is a gas, and carbon dioxide is a gas, and that water is a liquid. With 2 elements, there's only one thing we can do, and that's to combine them, so this has to be a combination reaction. Gallium is in group 13, which means it'll form a positive 3 ion. Iodine's in group 17. It'll be a negative 1, so we'll need 3 iodines to balance out the 1 gallium. So to balance the equation, because iodine comes in pairs, we're going to have 2 galliums, and then 3 iodine molecules will make 6 iodines, and that'll give us 2 of the gallium iodide. Physical states, gallium and iodine are both black on the periodic table, so they're solids, and gallium iodide, of course, will be aqueous because iodine has a charge of 1. Okay, this reaction has the ABCD type of format, so it's going to have to be some type of double displacement reaction. Palladium, because there are 4 nitrates, has a positive 4 charge. Carbonate's a negative 2, so we would need 2 carbonates to balance the palladium. Sodium is a plus 1, nitrate is a minus 1, so it would have to be 1 sodium and 1 nitrate. To balance the equation, we have 1 palladium, 4 nitrates means we'll need 4 of our sodium nitrate, and with 4 sodiums, we would need to have 2 sodium carbonates, and now we have 2 carbonates and 2 carbonates. Everything is balanced. For physical states, nitrate has a charge of 1, so the first compound's aqueous. Sodium is a charge of 1, so this one's aqueous. In the third case, palladium is a plus 4, carbonate's a minus 2. 95% rule says this will be insoluble, and it's a solid. And then, of course, both sodium and nitrate have a charge of 1, so this one is aqueous. So because we formed a solid, this has to be a precipitation reaction. This reaction also has the AB plus CD format, so it also has to be some kind of double displacement reaction. Zinc is a plus 2, and sulfate is a minus 2, so we'll need 1 zinc and 1 sulfate. Lithium is a plus 1, acetate's a minus 1, so we will need 1 lithium and 1 acetate. To balance the equation, we have 1 zinc and 1 zinc, so that's good. 2 acetates on the left means we'll need 2 lithium acetates. And now we have 2 lithium, and we have 2 lithium, 1 sulfate, 1 sulfate. Everything looks good. For physical states, acetate has a charge of 1, so this is aqueous. Lithium is a charge of 1, aqueous. Sulfate, although these both have a charge of 2, sulfate was one of our exceptions, and therefore this will be aqueous as well. And then, of course, lithium and acetate both have a charge of 1, so this will be aqueous as well. All 4 compounds are aqueous, they're all ionic and thus dissociate completely, which means we have no reaction.